Wednesday's work at home day due to the no power. So we are continuing with our Unit 3 on function families. And so you can see a little bit of a review here of what we talked about last week. We learned about the 3 different families, so the lines, parabolas, linear, quadratic, exponentials, their graphs, how they grow, their parent functions. And then we also looked at and added the absolute value and the square root function. So we have 5 different function families that we've been looking at. Okay, and so now we're going to look at some of the transformations of these, and that you did some of these already, so this one hopefully will be a little bit of a quick and just some kind of more review and specifics of those. Alright, so you should have this. You'll need to make sure you print these. They are linked on the Canvas page. No, they're not on the Canvas page. I will link them on the announcement with this video. So make sure you print these. If you haven't, pause the video and go print them real quick so you can have it to fill out. Okay. So connecting representations. I have some slides that go with this. As it loads. All right. And loading. All right, here we go. All right, so we're going to look at and connect some transform graphs to transformed tables. And the reason why we're going to do that is we want to practice thinking like mathematicians by using structure, mathematical structure, to connect 2 things that look different. So this is one of these real life processes, Common Core math process skills, to be able to look at 2 things that look seemingly different, but to actually find connections in them. And that's a really good skill to have. All right, so our process is we're going to think, make connections. This is going to be a little bit harder because you can't just sit there and tell me what you notice. So I'll just have to kind of go through and point out some things. All right, so the first thing we want to do is just ask ourselves, how are the graphs similar or different? And what are the chunks of these graphs? Okay, so I'm going to actually go back to our screen here. Okay, and if we look here, here's the graphs. Okay, so I want to know how is within each set of graphs, how are these 2 graphs similar and how are these 2 graphs different? So take a second, if you want to pause the video just for time's sake, see if you can come up with a couple of things. So one of the things that I notice with these 2 is that all of these points are 2 spaces apart. So there's a difference. I can see all of these got shifted up 2 points. Okay, so I can see that this one has been shifted up 2 points. Okay, so now let's look, let's go ahead and move to this one. This one is also, we can notice between these, this one is an exponential graph. And so that's something new, looking at transformations. We talked about it, but looking at transformations in other families. So if we look at this one is also an exponential graph. And so if you want to pause and think, how are they similar? How are they different? So similar in that they're both exponential. So let's look and see. This one, it went up a half a point, a half a unit. This one went up 1. This one went up 2. So I can't say that it's all shifted up or down because it's not the same. Okay, but what I can, so this one So when I did this with my San Diego students, they were saying that the growth rate was different. So this one has different growth rate. And we might, let's see, we can identify, if you remember, the parent function for exponentials always go through the 0.01. So this guy is actually going to be the parent one, the dashed one. And then the same thing here, this guy right here is the parent function. We can see we have it at 0,1. So we can notice this guy is down. We'll come back to it. Yeah. All right, so this next one, they're similar because they're both the same family, which is the quadratic family. And if I look, I can see the points aren't the same. Here's my parent function. And I can see this one went down 2, this one went down 2, and this one went down 2. So they are all shifted down 2 units or 2 points. And then our last set of graphs is also quadratic. And then once again, this dashed line is our parent. And let's see if we can see how it is different. So hopefully you're saying that it is moved to the right. So this went to the right, this went to the right, this went to the right. So it is shifted right 1 unit. So that's how these are, some of the chunks of these, how they are similar and how they are different. So the next thing we're going to do, so we looked at the graphs. So now we want to connect them. So now that we've looked at those, can we connect the graphs to the tables? Okay, so hopefully I'm going to give you, so what I want you to do right now is pause. So notice there's only 3 tables. One of these isn't going to have one. So I want you to pause this and try to graph and see which ones you think. And then once you think you have it, hit play and I'll tell you the answer. All right, welcome back. You better have hit pause and did this. Okay, so let's see. For the one that is shifted up, so notice it doesn't give me the equations. These are all just general f of x. I don't know the equation. It's just saying here's my function. Okay, so to move up, we talked about when something gets added on the outside right here, it's going to shift it up 2 points. So graph A should be connected with number 2. And if you want to put that over, on the front side, so we're going to connect, so we can put here C graph for notices, what we notice, C graph for descriptions. Okay, so we connected, so there's A, B, C, and D, and we connected graph A to table 2. So graph A goes with table 2. And the reason why is we can see that it was added to on the outside. So our x values aren't changing. So for one, so we have the 0.01, and then for the other one we have 0.3. And then we can see when it's at 1, the parent graph is at 2, the other one is at 4. So we can see that. So the reason why is because we added 2 on the outside to shift the graph up. And then for the next one, so now since we added 2 on the outside, let's go to the inside of the parentheses. And so hopefully you remember when something is added or subtracted inside the parentheses, it moves it left or right, and it's the opposite. So if I subtract 1, it's going to shift it to the right 1 unit. And we can see that that's what happened here with graph D. So graph D goes with table 1. So table 1, and the reason why is we subtracted 1 inside to shift the graph right 1. This one went up 2. All right, so we've used A and we've used D. So now we're down to graph 3 or table 3, and we have B and C left. So remember when we talked about the multiplier always changes its growth rate. And so when we multiply it by 1/2, it's going to grow 1/2 as fast. And that's the one that we could see up here with graph B. So if you notice, the parent graph was at 1, but the transformation grew 1/2 as fast. It's down here at 1/2. So we can see it has, the parent was 0, 1, the transformed is 0, 1/2. And then our next point, the parent function is 1, 2, but, so we see that right here, but the transformed graph is 1, 1. So we can see that this is growing. It changed our growth rate. So let's go back. So that was graph B goes with table 3. And it was growing 1/2 as fast. So we multiplied by 1/2. So that leaves for our next one. So we're going to create a representation to match that. So we're missing graph C. So let's take a look at graph C right here. And I'm going to cheat and make a, and just copy it so I don't have to switch back and forth. If you want to kind of, ooh, that was loud, sorry. And drag that guy in here. So there's our graph C. And we're going to make a table that goes with it. All right, so let's start off with our parent function so we can see those points A, B, C, and D. So we have X and then I have, so my X is at 0, 1, and 2. So 0, 1, and 2. And our, oops, 2. And then next is going to be f of x, so that's our parent function. So at 0, it's 0. At 1, it's 1. And then at 2, it's up 1, 2, 3, 4. And then we're going to put our y coordinates for the transform graph. So we can see here, this one is at -2. This one is at -1, and this one is at +2. So now we need to figure out, well, what's happening? And so hopefully you remember to shift something down, that happens outside of the parentheses. So that's going to be f of x, and to go down, we subtract, and on the outside, we said it went down 2. So that would be the general rule. So f of x says whatever this original equation is, it goes down to. So let's kind of talk about that, because we're not used to seeing this. You're used to seeing the rule like in vertex form, but f of x can be any general rule. That's our output. And so it could be the parent function like we talked about. It could be the absolute value. F of x would be this, or it could be the square root of x. And so the parentheses is the operation that's happening. So for like quadratics, the parentheses would happen before the squared term. For exponentials, our operation is the exponent. So our parentheses would be what's happening to the x in the exponent. For absolute value, we won't have parentheses, but we have the grouping symbols, and that's our absolute value bar. So it's happening inside the absolute value bars or outside. And then for square root functions, our grouping symbol is the square root symbol. So something is happening inside of it or outside. Okay? And it's going to be those same rules. So let's summarize these and reflect. Okay? So if we have f of x, so any function, whether it's quadratic, exponential, absolute values, square root, whatever that parent function is, that operation, if I add or subtract a number outside of it, it's always going to move it up or down. All the points, okay? Up if it's positive, down if it's negative. Okay, that's that vertical translation, okay? If I do something inside the grouping symbol before the operation, so before I square it, before I do the exponent, before I take the absolute value, before I square root it, that's going to be that. So this is the vertical change. Wow, my pen is not writing. Sorry about that. So this is going to be our horizontal shift, all of the points. And so remember, it's going to go either right, and that's if it is a minus h, or it's going to go left, and that's if it's a plus h. And then on the outside of it, we have our multiplier, so a times f of x, and this is two different things. So it's a vertical reflection. So that's if it is positive or negative. Remember, if it's positive, it goes up, or if it is negative, it reflects it across the x-axis and opens down. And it is a stretch or compression. And remember, the stretch is when that a value is greater than 1, and then the compression is when it is less than 1 but still greater than 0. And really it's absolute value, because the same thing's true with negative, if you remember that. So those are the transformations. I do want to show you one new one, and this one will pop up, I think, on your transformations focus area, I think. And so it is actually, so it's by putting a negative inside the parentheses, 2x. And let me show you what happens with that. And that one's actually easiest to see on the square root function. Let me figure out where I'm going. Let's go to Desmos and get a new screen. So let's start with y equals the square root of x. So there it goes. We can see it. That's parent function. So now if I stick a negative inside before I square root it, notice that it flipped it across the y-axis. So we call this a horizontal reflection. And the same thing is true for like quadratics and absolute value functions, all those others. It's a little bit harder to see. So if I do, let me put my parentheses around this guy. If I flip it right now, we really can't tell because it's symmetrical on both sides. But if I shift it first, so add 2, then I come back and I hit that negative in front of it, then we can see that it flipped it to the other side. And the same thing goes with the absolute values. So that's a new one. That's a, so this one is going to be, we call it a horizontal reflection. It goes across the y-axis. Okay? All right, so that's one activity. Let's just look at a couple. I want you to see how some of these transformations work when functions are not in like vertex form or that typical form. So you should have this next worksheet attached, okay? So let's look at these. So we're looking at starting off with a linear function, and its graph is 3x minus 6. So then if we look over here, so from f of x to g of x, it tells me that f of x was translated 3 units to the left. So from here, if I go 1, 2, 3, we can see we have that point right there. So kind of following this. Linears are a little bit tough because when you move them left and right, they also look like they move up or down. So you have to kind of just pick one or the other to focus on. This one is telling us horizontal. So we can see all the points, like right here. We can follow this one, 1, 2, 3 to the left. We can see that it ended up right there. So how did they figure out this equation? Well, if I want to go 3 units to the left, that means I need to do something inside the parentheses or with x. And if I want it to go left, I am going to add 3 units. So I'm going to add 3 units inside this equation. So if I take this equation and I take that x and I add 3, and then I have the rest of my equation, so that'd be minus 6. So I took this equation right here and I took x and I added 3 inside parentheses first. It should create this equation. So if I simplify this and distribute, I get 3x plus 9 and then minus 6, and if I simplify that, 9 minus 6, I get 3x plus 3. So we can see that that's the equation. So now let's look at k of x. So we're going to describe it from f of x to k of x, and let's see what happens. So it was at 2, now it's over at 5. So it started here. We can see that it shifted 1, 2, 3. So f of x shifted 3 units to the right. So that means if I'm going to take this one, if I want to go to the right, I'm going to subtract. So we are going to subtract 3 from inside the parentheses with x. So I take my original function And that x, I'm going to put it in parentheses and subtract 3 and then finish my equation. So if I simplify this, we distribute, we get 3x, and then minus 9, and then minus 6, and then if I simplify this, negative 9 minus 6 is 3x minus 15. And I bet if we could follow this line down, it's going to have that y-intercept all the way down here at negative 15. So the equation for k of x is 3x minus 15. All right, so let's try a couple more of these and then we will be done. All right, so let's look at parabolas. So notice in parabolas, it's not in vertex form. So let's see if we can transform it even when it's not in vertex form. So here's my parent over here. Here's my graph. So let's actually go to this one. This one says we took k of x and it is translated 1 unit to the left. Okay, or let's actually look at this. Let's start with this one. So this one in factored form, we can see that our x-intercepts are at a positive 2 and positive 8. So we can see that right here. Boink, boink. If we go to this one, we can see our x-intercepts are at a negative 2 and positive 4. So if I draw a quick sketch of this, so here's my y-axis, here's my x-axis. So we have at 1, 2, we have a point at negative 2, and then 1, 2, 3, 4. And it's going to have that same growth rate because they're all multiplied by a half. So it's going to have the same basic shape. And that's really bad looking, but you get the idea. So here at negative 2, right here it's at positive 2. So I can see that it went, so the original one was here at negative 2 and positive 4. So I could see that it shifted 1, 2, 3, 4 this way. This one went 1, 2, 3, 4. They're counting by 2s if you notice. So the transformation went from k of x was shifted right 4 units. And if I want to shift something right, then that's going to happen inside the parentheses, left and right, and to go right we actually subtract. So that means we would subtract 4 inside the parentheses with x. So if I take this original function, so that's 1/2 of x plus 2, and then I subtract 4 inside of that, and then I have to do it to every x, so x minus 4, that's the original one, and then I subtract 4 again. Then I can see that we get 1/2. This becomes x minus 2, and then if we simplify, so that was these two, and then if I simplify these two, we get x minus 8. And we can see that that is the equation. So do you see how these transformations are working even if it's not in vertex form? All right, let's look. So that's another one in vertex form, another one. Let's skip that page. If you want to go back, I don't like this one because to me it's changing the parent function. It gets a little wonky. So let's look at an exponential. Let's do this last one right here. Okay, so here's our parent function. We can see that it starts here and it got multiplied by 3, so it's still multiplying by 3. So let's pay attention. So there's an easy point to follow. So that should be here. So we can look and see if it's going up, but notice the thing that got changed was to x. And remember I said in the exponential, that's like inside. Otherwise, if I wanted to move it up, I'd have to add it over here. So like for an exponential, if I wanted to shift it up, the x would be here, and then I would have to like add numbers out here to the side. So this would be the vertical transformation. And so that's not what we're seeing here. So, but we can see, okay, here's this point. Let's look at these horizontal ones. It was right here. So I can see that it was here, but then it shifted 1 unit left. And so, so the function f of x is, and we said shifted 1 unit left. So if we want to move left, that is going to be adding 1 inside the x parentheses. And so it's not really here, but that is the before the operation. So we take our parent function 3 times 2 to the x, and we have to do it to the exponent, not after. So that's why it's the add 1 up here. So for this one, without looking at the graph, we see that it is a -1 up here. So this tells me it has to be a horizontal shift. And so since it is minus, that is going to be a shift to the right. And since they subtracted 1, it's going to be right 1 unit. So that means this point should go to the right one. And we can see started here and it went right 1. Okay? Alright, so what I want you to do, and I will check because I can see this, remember. Okay, I want you to do a little bit of practice. So if you go here, so make sure go to Student Desmos, and I can tell and see when you've logged into this and I can see your work. So I'm going to check this. So I want you to go here, type in this code, and it's going to bring up, I think it's like 5 or 6 different ones, and it's going to be a quadratic function and then an absolute value, a square root. So it's going to hit these different families, and it's going to give you a graph, and you have to figure out what's the parent function. So based off of what you know, go back here. What's the parent function? So figure out which one of these it is. So start with your parent function. Then figure out, use your transformations. Does it happen inside, outside? Is it a multiplication, a stretch or compression, a flip? And you're going to have to write the equations. Okay, so that's the last thing I want you to do. And then you'll have your checkpoint that you'll need to complete, as well as your notes for, I believe it was lesson 6. Where's my lesson plan book? So your notes for, your homework and, here we go. Yeah, your homework and quiz for 6 was due today, Wednesday. Hopefully you're probably watching this on other functions. So you need to make sure that's ready to turn in when you come back from Thanksgiving. And then I've linked in the first announcement, and it's also in Canvas, the new notes and homework. I believe this is your last section for this semester. Yeah, so this is your last set of notes and homework, 7 on inverse functions, and that note 7 on inverse functions is also going to be due the Monday. So you'll have the homework that was due today, homework 6 other functions, And then Monday when we come back from Thanksgiving. So besides that, you should have also finished the checkpoint for this assignment 3.3, as well as the new notes assignment 7 on inverse functions. And you'll have to print that either from the announcement I made or from the Canvas assignment. So make sure you're checking Canvas and paying attention to due dates on that. And if you have any questions, shoot me an email. I'll be checking my email probably through Monday of next week before Thanksgiving comes, and then that weekend, probably that Sunday again right before school comes back. All right, guys, have a great one, and I'll see you after Thanksgiving. Don't eat too much turkey.